Hi everyone, grade 12 mathematics presentation by Sir George. This is where you can contact me. My lesson today is on sequences and series. We are going to understand what a sequence is, what a series is, and what kinds are we to cover as grade 12 learners. Now, from this, a sequence is a set of ordered numbers with a pattern in which there is a specific or obvious rule for obtaining the next number or term. Now, what does this mean in the maths world? I give an example here. Consider the numbers 2, 4, 6, 8, 10, and the 3 dots means that the list could go on up to infinity. I just ended on this one, but this is not the last term, it goes up to infinity. Now the numbers are in order and you add 2 to the preceding number to get to the next one. For example, if I add 2 to this number, I get 4. Add 2 here, you get 6, and it goes on. Add 2 here, you get 12 to the next number, and it goes on and on like that. But what then is a series? Because if you are to check this, the numbers are just listed separated by a semicolon. Now what then is a series, and why is it different from a sequence? A series is now refers to the sum of the terms in a sequence. From this, once we start adding the numbers or the terms that are in a sequence, we are producing a series. 2 plus 4 plus 6 plus 8 plus 10 plus it goes on. Now this is a series. This was a sequence, we just listed the numbers. When we start summing them up, we are producing a series. Now there are important things that you need to understand when it comes to this world of sequences and series. We have different kinds. Some series will be finite or some will be infinite. Now what differentiates them? A series that approaches a certain limit, that's the finite series. And in this, the last term is known. For example, if I am to give you a series here, 2 plus 4 plus 6 plus 8 plus 3 dots, indicating that there can be several terms that come in between here, and then we say plus 16. The plus 16 is the last term of this series. The last term is known, it's 16. That's what makes this one a finite series. But when we speak of an infinite series, the last term is not known. We do not know where this series is ending, and normally they denote this. If you are to see or check questions or in other books, you will see them denoting a series that is infinite by 3 dots at the end. For example, 2 plus 4 plus 6 plus 8 plus then 3 dots. It means that this one will go up to infinity. The last term is unknown. That is what makes an infinite series. So from this, we have finite series and infinite series, and these are the definitions. Now we will later cover how do we use this, why is it important to understand this these definitions. Now we also have types of series that we are going to look at. We have arithmetic, geometric, and the quadratic. Understanding their differences will help you when it comes to answering questions. Remember, in an exam, it's not always the case that they state which series it is that you're dealing with. It will be your job to identify which series it is before you start applying the knowledge that I'm going to give you now. Okay, so on arithmetic series, I defined a linear pattern in arithmetic sequence with a common difference between consecutive terms. Okay, arithmetic sequence is a sequence of numbers with a common difference between consecutive terms. Now my mark is on this one. Common means it's the same across terms, across the consecutive terms, and difference, mathematically, it means you are subtracting. So if you are to look at this example that is above here, I have the terms 2, 4, 6, and a reminder, this is not a series, this is a sequence. Why? Because I am not adding the terms, I'm just stating them, separating them by a semicolon. Now, if you are to look at this, the difference between this term and its preceding term is 2. 4 minus 2, that's 2. And also here, 6 minus 4, that's 2. 8 minus 6, that's 2. That's why we are saying the difference between the terms that are next to each other is common, and that answer is 2. This is another way you can identify an arithmetic sequence with. You will see after completing this whole set of sequences and series that it is important to understand ways of selecting which one, or identifying or recognizing whether you are dealing with arithmetic, geometric, or the quadratic. Now, having said all this, a common difference is a constant term added to a preceding term to get to the next term. What it means is, for me to come from this, I need to add this constant that we discovered by subtracting consecutive terms. So I say plus 2 to this number, I get here. Plus 2, I get here. Plus 2, I get here. Plus 2, I get here. But questions don't just end in saying, find the next term of this sequence. No, they can ask you for the 50th term, 100th term. So adding manually becomes tiresome. So we know that maths in its existence tries to simplify the world around us and make us understand it better, which leads us to this: how do we find the nth term of an arithmetic series? Now, if you are dealing with an arithmetic series, there is a formula. That's the beauty of maths again. You are guided by formulas and rules and laws and theorems that you can apply to get to the answers in simplifying your work. Tn is equals to a plus open bracket n minus 1 d. Now we need to understand what each one of these mean. N is the nth term that we'll be looking for. We will see with an example how this works. A is referring to the first term of the series that you are dealing with, and D refers to the common difference. Now, having said this, you need to also note that Tn equals to A plus n minus 1d. This formula that I just gave you for finding the nth term is also seen as the last term. It represents the last term L. Now, this knowledge I brought it up because of the formulas that are needed on something special you need to understand also about arithmetic series. So far we have known how to find the nth term, but we said in arithmetic series we are dealing with the addition or the summing up of terms of a sequence. Now, how do you sum up n terms of an arithmetic series? Now, there are two formulas. The first one, Sn is equals to n over 2 open bracket 2a plus n minus 1 d, or the second one, Sn is equals to n over 2a plus l. Now, this formula that you are seeing as the second formula here, it is coming out of this part that you are seeing here, connected to the information that is above. If you are to check closely, 2a can be written as a plus a, then plus everything else. So if I have a, that a is this one. Then the other a goes to a plus n minus 1d, which is exactly what we regarded as the last term here. A plus n minus 1d is the last term. That's how to get to this. So if I have two formulas for finding the nth term, how then do I make a choice? Which one do I use? Now we get back to the definitions that I gave you of a finite and infinite series. In an infinite series, you cannot use this formula. Why? Because you won't be knowing, or you won't be provided the last term. So this formula is limited, which means all the calculations of the sum of the n terms of that arithmetic will be depending on the first formula. But what are these that we are seeing here? N refers to the number of terms. So the questions will come and say, find the sum of the first 10 terms. N is representing that term, the number of terms that you are summing up. And A is representing the first term. D refers to the common difference, and L to the last term. Now, having said this, this is like peeling a potato. Let's see how the salad is made. That means an example that comes from an exam itself. Okay, DBE Mathematics Paper 1 in 2015, question number 3, if you have to check it out. Consider the series Sn is equals to minus 3 plus 5 plus 13 plus 21 plus 3 dots, then to n terms. That's how it goes. Now, the first question says, determine the general term of the series in the form Tn is equals to bk plus c. Now, let's start by understanding the questions. This is where most go wrong. We need to understand the question that we're dealing with. Alright, if I am to deal with this, you see they did not specify whether it's arithmetic or geometric or quadratic. They just say a series. And surely it is a series because we are seeing a summation of terms here. And if you are to check, how then do you know which ideas to use? Yes, we are asked to find the nth term, but using which formula? You will see it makes more sense after covering the other types of series here. So with this, we need to see if we have a common difference. if you look at this term minus this, remember it's common then difference. We are subtracting the next term minus the previous term. That is always the order. Do not say this one minus this. It's always the next term minus the preceding term. So in this case, you will have 5 minus 3. That will be 5 plus 3, which is 8. 13 minus 5, that is 8. 21 minus 13, that is 8. So the difference between consecutive terms is common, which means, in other words, I have a common difference. Now this means that I am dealing with an arithmetic series. Having identified that I'm dealing with an arithmetic series, there are important things we discussed: finding the nth term and finding the sum of n terms. Let's put that to work. Determine the general term of the series in the form. This kind of a sentence is looking for an nth term. There is no sum mentioned. We are not going for those two formulas that we discussed on finding the sum of n terms. We want to find the nth term. So in general, which means my n remains. We are not substituting. They did not specify how many or which terms are we summing up. Now, the first thing you need to do after knowing it's an arithmetic series, you need to write down the formula. And normally you also take down the data that you are provided. This simplifies your work and eliminates some doubts that you might be having about something. Alright, so a plus n minus 1 d. This is the formula we discussed for finding the nth term. But this question is not just stopping at an easy way. They are specifying the format they want. So let's do it. We know that a is representing the first term. In this series that you are seeing here, the first term is -3. That's what I'm substituting here. And the n is remaining n because we are finding the general, the nth term. N is remaining as n. But d, the common difference, we said it's 5 minus 3 here, you get 8, or it's 13 minus 5, it's still 8. That's why you're seeing for d, I'm substituting with 8. Having done that, if you are to check here, the format that we need to end up with is bk plus c. You are not solving this. You are reducing this up until it looks similar to this one. Okay, having done this, we are getting back to the simplest maths ideas that we were given in the earlier stages. Here we need to expand, which means 8 has to multiply everything that is in this bracket. So it's 8 times n, that's 8n. 8 by negative n, that's negative 8 by negative 1, that's -8. In the end, we need to combine the like terms. This term and this one, they do not have n. I can add them. -3 minus 8, that's this -11 you are seeing. And the positive 8n is right here. Now, at this point, yes, you can say you are done. Why? The final answer is needed to be in terms of bk plus c. My b in this case is 8. My k, I've left it as n. My c is -11. You are done. This is the format they needed. Let's see also how they can ask you another type of question. Write Sn in sigma notation. We will come back to this example after discussing what the sigma notation is. So for now, I am skipping this part. We will discuss it after knowing what this means. Now, another part that leads us to what we need or what we have covered up to now. Show that Sn is equal to 4n squared minus 7n. We have done a simple lesson on arithmetic series, but in an exam like this one of 2015, you are seeing them wanting you to prove this. So it's not about guessing, it's about recalling the ideas that are needed to get the job done. How do you manage that? Look at this. 4n squared minus 7n is what we need to show. A question that says show that, it means this is the solution you need to get to. You are not touching this. You are starting elsewhere and reduce up until you reach this point. How do you do that? They mentioned Sn. From the lesson, I learned that Sn represents the sum of terms. So, n over 2, 2a plus n minus 1d is the formula I'm going to use, where I know that n is remaining because where I want to reach, n still remained there. That's how they show that questions guide you. By looking at this, you also see what is to remain in as part of your solution. Now, what else can I substitute? We know that a is -3 and d is 8. Now the other job that is left is simplifying all of this. So n over 2 open bracket, this by this you get minus 6, 8n like we expanded, then minus 8 we have this part. If you are to add minus 6 minus 8, you get minus 14. The positive 8n here comes down as it is, and the n over 2, the part of the formula, is still there. But looking at where we want to reach, I need to simplify until I reach this part. So I need to multiply everything inside by n over 2. How do I do that? If you divide this by 2, you get 4. 4 times the n that you have, that's your 4n squared right here, minus. If you multiply here, you have 4n divided by 2. So the 14n, will divide by 2, and that's how you get your 7n, and you have proved it. So you have started elsewhere, reduced following the simple algebra steps, then you reduce up to this point. It is about getting the idea. What am I dealing with? What did I cover in class? What is this sign referring to? That is why we say it is important to understand the definitions and the notations when it comes to this maths. Now at this point, after doing this arithmetic series, I am going to stop, and please, I will come back again continuing from here, giving you the geometric together with its properties and also its examples. So please, to those who will be in need of finding me, you can contact me at this number. And please, when you get to this video, subscribe, give your comments, and also give on your ideas. It will be helpful. We need to reach out to as many as we can and give people the love for the subject. Once again, I thank you.